Okay, so question 1 is about electrical circuits. Which quantity is defined as the rate of flow of charge? Okay, so this word rate here, basically every time we see that in physics it means divided by time. Okay, and it's the flow of charge, and the symbol that we use for charge is Q. So hopefully if you look that up on the formula sheet, you'll see that I is Q over T. Alright, and that means that current is the correct answer for 1A. For part B, which quantity is defined as the energy transferred per unit charge passed? Okay, so this is the energy transferred, so that's measured in, energy transferred, so the symbol for that is E, okay, and then it's per, so the word per means divide, and then unit charge, again charge is Q. Alright, so again look in the formula sheet and you'll see that the relationship is V equals E over Q, okay, which might be expressed like this in the formula sheet: E equals V times by Q. Okay, so that one is going to be voltage. Moving on, then we've got to try and work out the different kind of descriptions for these graphs, right? So first of all, this graph is a straight line which passes through 0, 0. So for this one, we know that current is directly proportional to time, okay? And that's important because there's two features that make it directly proportional. One is that it's a straight line, the second one is that it's through the origin. Okay, so for example, graph Q is not directly proportional. Why? Because it doesn't pass through the origin, right? So it's linear because it's a straight line. Okay, if you're in a maths lesson, you'd want to write down y equals mx plus c for this one, okay, which is the equation of a straight line. Okay, but because c is non-zero, okay, it does have an intercept here. All right, that means that it's not directly proportional, right? So the best explanation for the best match for this one is current has a linear relationship to time, but it's not directly proportional, right? Okay, and then moving on to the other two, current is, if you look in this graph, then current is increasing, and if you look in this graph, current is decreasing. So in this one, current is increasing, but at a decreasing rate. So at the beginning, it's increasing quickly, and then not so quickly, and then it's still increasing, but not by very much at all. So current is increasing, but at a decreasing rate. Okay. And for this graph, you can see that current is decreasing, okay, and again at a decreasing rate. You can see that initially it's decreasing quickly, okay, then not so much, okay, and then not so much, right? You can see that in each of these kind of units time, there's a big change in current to begin with, and then there's a smaller change in current during that moment in time, and then here there's a really small change in current during that unit of time there. Okay, so graph R is current is decreasing at a decreasing rate.